really say sort of the past, present, and the future of this landscape are not separate stories, but they're one. And I look forward to how this will work in the future. So with that, I just want to really say thank you to my colleagues. Thank you for listening. Thank you to the Dashnich community who, over the course of many field seasons have literally saved our lives up in northern Kenya, and to my colleagues here at the National Museums of Kenya who have been a partner. And I first came to Kenya, I was only 19, if you believe it, and I've been here every summer since then, and really here the National Museums of Kenya is sort of my home away from home. So thank you very much for the opportunity.
Thank you, Professor Brown. That was quite interesting. I was wondering how will the archaeology come to the present, and you've made it very clear. And I believe everybody has appreciated that, especially if you're not in that field. So we've come to the end of the keynote presentations, and we're going to take about 15 minutes to ask any questions, clarifications, or if you have new ideas that these researchers can take on with their projects, then all those are welcome. But let's give him a round of applause. I keep forgetting about that. Thank you very much, our two keynote presenters. Interesting work. And I now want to give the opportunity to any questions, suggestions, clarifications. And how we are going to do it, we'll have like 3 or 4 people asking questions. And then you have to be clear who the question is directed to. And then we'll give the presenters some time to respond, and then we'll have another round. So feel free to just lift up your hand. I'm hoping there's another mic around so that somebody can take it to the people asking questions. Do we have? Okay. Okay, we have a question there. That's one. Any other? 2, 3. This side. Okay, let's start with that. I believe thereafter there'll be many questions coming in. So let's start with him. Are we going to get a microphone for them? Did you get it? Okay. Now there's a second hand over there. Please be loud until we get the microphone. So you want that tourism to be enhanced by improving the infrastructure to that place. It's a suggestion. So I hope the people are hearing, those who are concerned. Okay, there's another hand over here. I hope the questions were clear. Most of the questions were going to Professor Brown. I hope the next round will be more to Dr. Mwangi. So maybe, Prof, you can respond to those, and then we'll give Dr. Mwangi that one question to respond to as you think of others.
I grew up around New York City, so I'm pretty loud. Hopefully everybody can hear me. I don't think I need a microphone. The question was about the G-Bay Dam and the impact of it on the lake. That is a real concern. I'm not going to wade into the geopolitics of water management between Kenya and Ethiopia. I would say that it's certainly possible that the G-Bay Dam has had some impact on Lake Turkana. The initial perception was, the prescription was that it was actually going to reduce the water in the lake. And it's quite the opposite of what's actually happened. The lake has actually risen quite dramatically. However, the fact is that almost all the lakes, or not all, many of the lakes in the East Africa Rift system are also increasing. And I mean, also know that Lake Baringo has also increased dramatically, so much so it's actually eaten lodges that are there. So it seems unlikely that both of those events are that whatever is causing lakes to rise in the rift system may actually not necessarily be connected to the G-Bay Dam, and maybe some other, associated with increases in overall water budget, and that's the kind of thing that definitely outside of my wheelhouse, but it seems like maybe disconnected from the G-Bay Dam specifically. In terms of infrastructure and connection to heritage, it is absolutely, it's a very clear question. How are people going to get there? How are they going to experience this heritage? And in some ways, I think it's a very forward-thinking way of the museum to actually get out in front of this. As we can see, I remember at a time when I used to spend a lot of time in Tsavo National Park, where it would take 5 or 6 hours to get there. And some of you may remember when the train used to take you overnight to get to Mombasa from Nairobi. All of that has since changed. And Mombasa Highway is a very different thing than it was in 1998. And so those things will change. But if we build the infrastructure for communities, sorry, I don't have to yell any longer. For heritage tourism now, that by the time the infrastructure for people to get there happens, it will already be in place. Right? I think if thousands of tourists showed up at the Illit Museum, we would already have a problem because it's not really built for that right now. But building it the way it is right now may allow us to the infrastructure can build when tourism gets there. It will have the scale up as it increases. So it does seem like it's a very far distant away place to build towards 100,000 people, but I think it's really forward thinking to do it now before it's going to be too late, right? Where you can do it from the ground up as opposed to from the top down. In terms of freshwater ecology, I will say that, and again, outside of my particular, I actually study rocks most of the time, but one of the things that we're really interested in is understanding the ecosystems that people lived in the past. And geologists have built a tremendous number of different proxies for understanding freshwater changes over time. We're right now building a mechanism to try to understand the alkalinity of the lake over time, because the lake is quite alkaline now, but it wasn't always. And there are ways to do that using biomarkers and geochemistry. And there are actually some really exciting facts. Venancio Maniaco, who I mentioned here, his postdoc, as far as I can tell, is actually to focus on some of those geochemical measures to actually understand freshwater changes over time. And he'll be doing that at University of Notre Dame. So I think I would refer to extensive number of geochemistry colleagues that actually work here at the NMK or are trained here that would know how to answer that better than me.
Thank you very much. Let's have another round of questions to the two presenters, the keynote speakers. Oh, sorry, I've forgotten that you're supposed to respond, please.
Just on the freshwater question. One of the ways to start just coming back to that, perhaps using the environmental DNA from the DNA. And we have a project in the DRC at a place called McDonald LBDA, where we constructed previous fish compositions in the lake by the DNA that is preserved in the sediment. So environmental DNA might be a way to study or to try and reconstruct past compositions. In terms of carbon sequestration, there's a whole new, not new anymore, not so new anymore, field of blue carbon, which is looking at mangrove, seagrass, and a lot of that stuff that is considered blue. But also there's been some controversy in the sector because of some, as I say, this whole idea that this is a public good problem, and so when some people feel governments are not doing enough, sometimes they take matters in their own hands. There's a controversial area on geoengineering involving iron ore, where if you deposit iron dust in water, there's a chemical reaction that means something, and it increases the level of algae and phytoplankton growth, which sequesters carbon dioxide, and once they grow, they go to the sediment and they are stored there. It's still very controversial because of why you do it. So some people go to the open ocean and say this is free for all areas, so they can deposit so that they feel they're doing something about it. But it's usually the controversial activities that are doing, because there are also other potential negative ramifications from doing such.
Thank you. Thank you very much, Dr. Mwangi. Looking this direction, any questions? The presentations were very clear, or they were new and you were just learning like me? Okay, there's one hand up there. Any other? Second? Any other? And third? And please be clear who the question is directed to, please.
I'm Itambo Malombe. My question goes to Dr. Mwangi. And I think I need to thank him for the clarity on domiciling the whole society in GBF targets. Maybe a small concern, or maybe to seek clarification from him, One, the Amboseli ecosystem changing, is it the governance as compared to what the Wildlife Works is doing in Taita? But also secondly, try to understand from him how the whole society, and especially the carbon credits, can also be a good take for the coastal forests, especially our kayas. And finally, I've seen his passion and his worry on how we really implement, whether nationally or globally, the idea of whole society. But through the Ministry of Environment, we have the national coordination mechanism for biodiversity. Whether he is aware of that organization or the discussion through the government structure. Thank you.
Thank you. The next question will come from him. Right over here.
Yeah, hello everyone. I'm Ian Moniki and I work in the coastal forest. My question has been asked previously, but just want to understand something from Dr. Mwangi. How can these systems help the kaya forest in the coasts? Because these are sacred forests that are managed by elders, and at the moment they are facing a lot of pressures, and as the young lads are coming up, it's being destroyed a lot. So if you can just tell us how you can help in this forest, it will be okay.
Just give to the lady right behind.
Good morning. My name is Victoria from Mount Kenya University. So I think from the two speakers I've heard about communities' involvement. And the question is, and all of us belong to one community or another, there's a crazy thing that is happening about pollution, and our paper will be talking about it a little bit, because we are focusing on the 14 faults that are based in Thika County. So my question is, how do you implement community-led conservation? Because I think this is a conversation that has not been spoken a lot, because we are destroying our environment through a lot of pollution, and probably conservation education needs to be a conversation that needs to be talked about a lot, so that we can be able to preserve our environment even for future generations. Thank you.
Thank you very much. I think many of the questions were directed to Dr. Mwangi, but the one of the community, I think, Professor Brown, you can also contribute to it.
I didn't quite get your question, Banomalombe, on Amboseli. So Amboseli has had the change of governance, but this. So what I'd say there, it could go either way in terms of conservation. So normally we say communities, because of the public goods problem, when there is not secure tenure, it's hard to do conservation because they don't have the tenure. But in places where there is increasing subdivision and tenure security, you're finding the opposite happening. So it's a kind of tenure that matters more than whether it's there or not. And we find that in Asia and South America a lot, where communities have customary tenure and it's not contested. and they don't know what a title deed is, but that it doesn't matter because it's not contested. So I think the question is, what is the tenure like, and what is the goal? So it's hard to say where Amboseli may go, but we also have the Chulu Red Plus project, and that is in Chulu Hills National Park and for group ranches around, and it follows a similar model as the Kasiga one with group ranches, only that this has Chulu there. But there's also a lot of subdivision around Kimana in some of the ranches, which might affect also the Red Plus project. In terms of the national coordination mechanism, I'm not sure I know about it, so it could be my oversight, so thanks for pointing it to that. And if it tries to, because I read the NBSAP and I see clearing houses, I see monitoring and evaluation, I see data exchange. I don't see how most, and not just the Kenya one, most of the places we work, we have to really interact with them. I don't see how they go beyond advocacy into action, really actioning farmers and other people to contribute to that, and really actioning people living in town. So if somebody is living in Umoja, what can they do about biodiversity? It's not just somebody who is outside Amboseli who should be concerned if you're whole of society. But really empowering this person to be able to meaningfully contribute is a real challenge. In terms of coastal forests, Kaya, it depends on the goal of the project. So as I said, like carbon projects and our biodiversity projects are very different in their setup and their goals. One is meant to offset an emission that happened somewhere else. The biodiversity project is supposed to reward stewardship. So for Kaya, in its normal situation, it would really fall in the second place, because for carbon projects, you need to show that you had an intent of cutting down your forest, so you're being incentivized not to cut it down. If you could have pressure, it could be within your community or outside your community, but you could have the pressure. But if you are really, if because of cultural and other heritage issues, you are actually maintaining your biodiversity, then you'd look more for an asset line that helps you maintain that. And some of them are very difficult to do. That complicated maze that I showed means that transaction costs are high, so the cost of developing projects can be quite prohibitive as well. So the markets may not be for everyone. Maybe these are places where you can look for grant financing, bilateral financing that is lighter on the market element and the assets as a social good. But the market may not be applicable for every situation out there. I think for the community, just briefly, community-led conservation is hard to say because communities are not homogeneous. So you find that some communities own the land, some communities are the ones that are drivers of the problem, and what you mean by community-led differs in those two. So for example, in Brazil, because these indigenous people own the land and own all the rights, they're in the center. The methodology, they have to own that methodology. Anybody using the methodology pays them. So they have the IPR, the rights to the intellectual property. In other communities, for example, in Kenya, you have the group ranches, which are collectively owned by community members, but they are private entities with their own constitution and AGM. And then you have the rest of the community who are not members or shareholders in the ranches. Both of them are community. So you have to engage the landowners because they are giving up their land in a conservation easement. But you also have to engage the other community because they are part of the solution. So how you do community-led there is slightly different. So I'd urge you to think about it not as a homogeneous one way to do it. Think about your community, where does it fit, and how best would they contribute to your goal.
Thanks. I'm not sure I can really speak to community-led conservation most likely just because the Illirit area is a very remote place. The conservation of the archaeological materials is important to us, but is not nearly as under threat as in the same way that the wildlife would be. I would say that I think the conservation of the heritage resources there probably starts within the community, and I'm guessing in education, in the sense that we build community members into the research project, but also we have members of the community who are in training. So it's really exciting. We actually have people who are from the Illirit community. They've gone to university who are now in our program and are part of the training. So then they will hopefully return to the community as part of these conservation and community building efforts. I think it has to come from within, and I think that's probably the only way to do it. So.
Okay, thank you very much. I think we'll end there so that we can break we can take a break. But when you listen to both keynote speakers, you can see that aspect of community engagement. And it would be interesting to look at how it was happening in the past when the community was not very involved, and what's happening right now, to see whether there are issues, differences, and if they are positive. So I would urge the two projects to have a look at that and enlighten people on that. So for now, I'll hand over to the MC so that you can direct us on what to do next. Thank you very much, and a round of applause for the two speakers again.
Thank you, Professor. We will now take a break for a cup of tea, and I'd request that we take 20 minutes exactly, because as soon as we are done with tea, we have the official opening of the conference. So welcome to a cup of tea. You will go on your left. There's a courtyard right behind here. If you go up out, there's an exit. There's a courtyard here, and tea is being served here. So welcome to a cup of tea. Thank you. leading team is requesting that we move to the breakout sessions. And once the team that is supposed to open the conference have arrived, we will be called from our breakout rooms to come back for the opening ceremony. So there are several breakout groups. There's a group that is staying here. There's a group going to the Natural Sciences Seminar Room. There's a group going to the D's Lab. And there's a group going to the old boardroom. So those are 4 breakout sessions. And I don't know if Dr. Patrick Malonza is here. I think your session, you're the moderator of the session here. So I'd like you to come and take over here. And the session is biosystematics, ecology, evolution, and biogeography. So that group will stay here. I don't know if you want me to, I think you all have this program, isn't it? Should I go through the list? So the presenters, the first presenter is Paul Kirwika, National Museums of Kenya. The second one is Zhang Ji Huang. He's from the Chinese Academy of Sciences. There's Jacob Mweti Ngwava, National Museums of Kenya. Veronica Onduso, National Museums of Kenya. Judith Nyamai, National Museums of Kenya. Lovisa Kandege, National Botanic Research Institute, Namibia. Beatrice Mukami, National Museums of Kenya. Angeline Mova, Kenyatta University. And finally, Edward Njagi, National Museums of Kenya. The Natural Science Seminar Room, the session moderator is Vivian Nandoka. She's here. If you can see the lovely lady in green. And the theme for that session or that group is climate change, adaptation, and mitigation strategies. We have Ucharia, Kenya, University of Embu, Francis Moshemi, National Museums of Kenya, David Kenfak, Mpala Research Center, Joseph Gadua, National Museums of Kenya, Stephen Kamesa. He's presenting virtually. He's from the University of the Chinese Academy of Sciences. Oscar Mirindi, University of Eldoret. Anthony Karani, University of Embu. Veronica Ngumbao, who is last but not least, National Museums of Kenya. So if you're here, I think you can go with Miss Vivian Nandoka to the seminar room. So that group can follow Miss Nandoka. And once we get communication, we will call you to come back for the opening session. The third group that is going to the D's Lab, their theme is biodiversity friendly and biodiversity friendly and climate smart agriculture. The session moderator is Dr. Mary Moshane. Is Mary here? Dr. Mary Moshane. Grace. I don't see Mary here. They are supposed to go to the D's Lab. Maybe we can reach out so that that group goes to the D's Lab. So, moderator is Dr. Mary Moshane from National Museums of Kenya. Nandoka, she has gone. Malonza, he's staying here. Yeah. Old Boardroom, Dr. Simon Musila. I think I saw him. So, this lab, the presenters are Ruth Kahuthia, Kenyatta University, Eric Modhama, University of Cambridge, UK. He'll be presenting virtually. Anne Kimani, Mount Kenya University. Odiwuor Vincent, University of Eldoret. Marcel Medugu, Modibo Adama University, Nigeria. Amran Isaac, National Museums of Kenya. David Moreithi, Kenyatta University, presenting virtually. Maranga Wycliffe Obara, Kenyatta University. This group is going to the DIS lab. Mary Moshane is the session moderator. Kevin Kipngetich, are you here? Could you lead this group to the DIS lab as they find Mary Moshane, who is the moderator? And also Dennis Mbandi, KU. I think you are the session rapporteurs. So that group, please come down here so that they go with you to the DIS lab. So if you had your name and if you're interested in this particular theme, which is biodiversity friendly and climate smart agriculture, please follow this gentleman. Mama tu hapo, then they come and then you go to the DIS lab. So the fourth group, Dr. Simon Musila. Are you here? Oh, there he is. Oh, nimetuma na Kipngetich ameenda DIS lab. Seminar room bibi anameenda, but one person can. Is there anyone going to the seminar room for the session Climate Change, Adaptation and Mitigation Strategies? Or they've all gone? They've all left. So one more group to go to the old boardroom because there's a group staying here. So old boardroom, the theme is leveraging digital technologies. And the session moderator is Dr. Simon Musila. I've seen him, he's here. So those who are making presentations include Fred Siambe Omweri, Machakos University, Dr. David Mbuthia from Heroes Research and Monuments, Alex Musyoki, National Museums of Kenya, Simon Gushu, National Museums of Kenya, John Opio, National Museums of Kenya, Immaculate Mungai, National Museums of Kenya, Morris Nzioka Mutua, National Museums of Kenya, Timothy Mwinami, National Museums of Kenya. Could this group please go to the old boardroom if you're here? And anyone who's interested in that can follow Dr. Simon Musila. The rapporteurs are Maxwell Abugri, University of Ghana, and Charity Barasa, University of Eldoret. Old boardroom, please follow, it's just close by. So the group that is left here is the biosystematics, ecology, evolution, and biogeography. Dr. Patrick Malonza please take the floor. Your session rapporteurs are Mary Stella Injete, University of Eldoret, and Irene Chepngetich, the Technical University of Kenya. Tuwatafutie viti. Come here. So please bear with us. We start earlier than expected because we didn't want to lose this time of the ceremony.
Thank you.
Tafutie kiti.
Oh yes, good afternoon. Yeah, can I have the rapporteurs get closer here, and also suggest that we are too much behind, so we try to come forward unless you are, and then I call upon our first presenter. But let me have the rapporteurs first, Mary Stella and Irene. Are they around? Oh, Mary Stella, are you Mary Stella or Irene? Okay, just have a seat somewhere there. Yes. So can you get closer, however few you are, but let me hope that. And then Kirika, our first presenter will be about plant diversity in some selected counties in Lake Victoria Basin, namely Kisumu, Migori, and Homa Bay. Paul? I thought I saw Paul Kirika somewhere. Otherwise, if Paul is not, let us give him maybe 2 or 3 minutes. If not so, we can, while he prepares, we can see whether the second presenter is ready. But let us give him some time. What of, as we wait for the other presenters there, for Paul, is Zhang Ji Hang present? Oh, you are?
Yeah.
No,
We don't have computer here.
you have a computer?
No. I need.
And the other person is Jacob. I can see Jacob here. Veronica, yeah, Veronica is there. Judith, I also saw somewhere. Judith Nyamai. Judith? Then we also have Lofisa Kadege and Beatrice Mukami. Sorry, the ICT guys, you. Has Paul Kirika come? Or is I think I'll call upon the second presenter if is ready. Is Zhang Hung. That's from the Botanical Garden of the Chinese Academy of Sciences. Because Kirika he has not shown up, so let us. And then you'll give us a presentation on pain patients back to impatience. That's on Eden Biodiversity in the Bashan Mountains in China.
They are still trying to fix together.
Oh, okay, fine. He has told me not yet, so they are trying to fix. You are. Kirika is here, so let us see what he has and. Try this. Yep. Is this one working? We are trying to connect using this. Kuna mali nafasi. It's supposed to pick automatically. No, this one is not. It's there. So, time is only 15 minutes, so I think for each of the presenters, we'll try to make sure that they don't spend a lot of time on what is not here for a lot, maybe some short introduction, then after that methods if it's a study, and then go to the results and conclusion discussion. Thank you. Welcome, Kirika.
Good afternoon. My name is Paul Kirika from the National Museums of Kenya. I'm going to present a study which was carried out around the Lake Victoria Basin of Kisumu, Migori, and Homa Bay counties. And this my so far. Uh, reason for all plants encountered in those plots were documented, and details about the vegetation structure also recorded. Specimens were also collected and later deposited at the East African Herbarium. The list of the species that were documented were also assessed against the IUCN Red List, and also against the CITES, the CITES database, and also for endemism. And then we also undertook statistical data analysis. And the results were that we recorded about 582 species of vascular plants. 145 species were extracted from the literature, and we compiled a checklist with about 727 species. We undertook the statistical analysis, we used data from the plots, which was about 412 species from 28 sample plots. And most species families were the legumes, and also the Asteraceae and the grass family had the highest number of species, as you can see on the graph. We also did species richness analysis, and Kisumu had the highest number of species, and we also compared this with the species that were found because we were working both on the farmlands and on natural ecosystems. And we have those diversity indices from the entire study and then from the natural habitats. And we also wanted to see how the vegetation was structured, and also the relationship between the various sample plots. And we did MDS, as you can see, and that is how the species congregated on the MDS graph, as you can see. In total, 8 species of conservation interest were documented, and this is, as you can see, Vitex fischeri, variety keniensis, which is an endangered species, and 3 other species of which are endemic to the East African region were documented according to the LEAP database. We documented 1 orchid and 2 aloe species, which are both listed in Appendix 2 of CITES. And also Oxalis lanceolata was quite common. And this is also, it's a species which is overexploited in the perfume industry, and there are a lot of, it's poached all across the country. And we recorded a new record for Kenya, Desmodium canam, which we came to know that it was recently introduced for fodder in Kenya. It's a recent introduction. The entire area had a high diversity of invasive alien species, and about 42 were documented, mainly in the farmlands and also in the natural habitats, because the natural habitats are also quite highly modified because of the disturbance, cutting down of trees and slash and burn, allowing invasive alien species to take up the large areas. We also documented some crop wild relatives, as you can see, relative of the sorghums and the tomatoes, and also in the yam family. These are some of the, just a list of the many invasive alien species that were documented across the region. Also, over 200 species, medicinal plant species that are used all across the country were also documented in the area during the study. We undertook an analysis of the importance value, and overall eucalyptus was ranking very high all across, because most of the farmlands were, people were cultivating eucalyptus, and some of the natural ecosystems have been converted into plantations. And as you can see, in different areas, different tree species were coming out of the importance value was different from across the regions. So Lake Victoria Basin has a rich diversity. However, it has it's low in endemism and also species of conservation interest compared to other regions. And the species accumulation curve, which we generated, did not reach an asymptote, in indicating that more species are yet to be documented from the area. The natural habitats are highly modified because of the rampant encroachment and charcoal burning and cutting down of indigenous species. There was also a high rampant of soil erosion due to cultivation in the very steep slopes, especially along the escarpments. This destruction has led to loss of ecosystem services that the communities derive from the natural ecosystem, then they remain intact. We recommended rehabilitation of the degraded natural habitats, especially using indigenous species, and also together with the local communities, because they are the source of the threat to the natural ecosystems, and also limiting activities on the steep slopes, especially farming activities, and also discouraging destructive agricultural practices such as slash and burn, and also to diversify livelihoods through environmental friendly activities such as cultural and eco-tourism, and also to that promote environmental conservation, and also further biodiversity studies to be undertaken. I acknowledge our supporters for this conference, and thank you very much for listening.
Thank you very much, Kirika. I think let us once again give him a applaud of applause. And he has also maintained the time. We have 15 minutes, and he has at least spent something like close to 13 minutes. Let's welcome our second presenter from China to give us a talk on Eden biodiversity in the Qinling Bashan Mountains in China. You will tell us where they are, and welcome. Sorry, we'll have questions and answers after the end of all the presentations.
Good afternoon, everyone. I'm Zhang Jie Huang from Xishuangbanna Tropical Botanical Garden, Chinese Academy of Sciences. Today, I'm honored here to present our work titled Patience Back to Impatience, Hidden Biodiversity in the Qinling Bashan Mountains, China. As many of you know, the genus Impatiens literally means impatience, also known as touch me not, referring to the explosive discharge of seeds from mature capsules when touched. However, unraveling the taxonomy of this complex group requires an immense amount of patience. The flower you see on the cover is a new species we recently published, Impatiens perforata. Let's look at the family Balsaminaceae. It consists of only two genera. The monotypic one is Hydrothera, only have one species. And another genus, Impatiens, have over 1,100 species worldwide. As you can see from the photograph on the right, they exhibit extraordinary monographical diversity. with flowers of various shapes, sizes, and colors. According to the previous phylogenetic framework, the genus Impatiens can split into two subgenus, genera, subgenus Impatiens and subgenera Clavicarpa. And the genus Impatiens can subdivide it into 7 sections, as shown on the tree. Geographically, Impatiens is primarily distributed throughout the Old World, tropics, and northern temperate regions. Of the 1,100 species globally, China alone hosts around 350 species, making it one of the most critical centers of diversity and endemism of this genus. So why we choose Qinling Bashan Mountain as our research study region? First one is the transitional region between temperate and subtropical zones. Secondly, it is the nature boundary of the North and South China. And thirdly, it is one of the biodiversity hotspots, being underestimated and lacking investigation. But we choose only part of it, Shanxi province, as a case study. It covers the highest proportion of Qinling Bashan Mountains. And until now, it don't have its own regional flora. When we look at the current literature, only 19 species of Impatiens are officially recorded in Shanxi province. However, the reality of the ground presents major challenges, such as taxonomic confusion. There are many species have confusing relationship between entities and the names. And we also find many specimens, unresolved specimens in our herbaria. So why is Impatiens taxonomy so notoriously difficult? It is because their flower is very complex, have complex floral structure, is three-dimensional, is very delicate. Once it's pressed in specimen, it's easy to be destroyed, the structure. But you can maintain the 3D structure in spirit specimens. However, the flower in the spirit specimen is too fragile to be further dissected once removed from the solution. So how we solve these problems? One is do extensive specimen inspection. And secondly, we should immediately dissect the fresh flower in the field. For our morphological work, we examined over 1,000 physical specimens and over 400 digital specimens. We also conducted extensive field work in Shanxi province and adjacent regions. For the molecular phylogeny, we utilized the nuclear ITS marker and 3 chloroplast marker, sampling 265 samples and 145 species. Our phylogenetic results shows that both the nuclear tree and the chloroplast tree support the current classification of 2 subgenera and 7 sections of subgenus Impatiens. But these two trees are typologically slightly incongruent. The section Impediens in subgenus Impediens can subdivide it into 8 major clades. We will talk about it later. The first question we solve is, which is the real Impediens Notolofa? In the history, people often recognize the lower one with the bigger flower as Impediens undulata, and the small one as Impediens Notolofa. But after we re-examine the type specimens of Impediens Notolofa, we discover that a long-standing error. The smaller flowered yellow flower is not Impediens Notolofa. It should be new species, both supported by the morphology and also the phylogenetic results. The second one is there Impediens compta or Impediens nasuta occurs in Shanxi province? After we examine the specimens collected in Shanxi province and the type specimen of these 2 species, we found that Impediens compta, even on the dry specimens, can see it bears yellow lower sepals and violet lateral united petals. But Impediens nasuta only possesses deep rosy purple corolla. So there is no Impediens nasuta occurs in Shanxi province. The third one is in Flora of China, the author said in Shanxi province, he found a new record of Impediens latibracteata in this region. But after we checking the type specimen of Impediens latibracteata, it shows orbicular, margin dentated brad as shown on the left. But the true, the one occurs in Shanxi province exhibits broadly ovate, especially margin entire brads. So the one occurs in Shanxi province should not be latibracteata. It should be a new one. We call it Impediens cortibracteata. Recently, we found Impediens latibracteata in Sichuan province, shows up there. Also, we discover a distinct cryptic lineage closely resembling to Impediens noditangere, a widespread species. It looks the same, but Impediens noditangere is not lower sepal is broadly infundibuliform. The misidentified one, the lower sepal is narrowly infundibuliform. Also, on our phylogenetic trees, it can separate easily. So we publish it as a new species. The next one is a very complex. Impediens pterocephala and its relatives. It contains many species as shown on the phylogenetic trees. Firstly, there are 2 classical species occur in Shanxi province, Pterocephala and Linocentra. Its major difference is the dorsal petals shape. Because of the lack of samples, currently we still recognize their species status. Furthermore, we evaluate Impatiens dasyvaxilla, published in 2020. Its diagnostic character from Pterocephala is Impatiens dasyvaxilla is whole plants densely pubescent or pilose. And the last one is a new species, Impatiens juii. It differs from Pterocephala with its top dorsal petal abapsally mid-vein crenated, near the top of the crest caudated as the tip of the dorsal petal. Here is also a very complex thing. It contains many species, and these years people keep publishing species with only one sample in this complex. But only 2 species occur in Shanxi province. After we checking the type specimen of these 2 species and also the living plants of these 2 species in the wild, we found that they are the same. Only one species should be recognized. To summarize, our work has updated recorded Impatiens species in Shanxi province from 19 species to 21 species. In parallel, we expanded our perspective to perform a comparative analysis of 21 species in Kenya, utilizing iNaturalist as our resources. Throughout this comparative research, we arrived at several key reflections. First one is that species boundaries are still unclear, both in China and in Kenya, and not only in the genus Impatiens. And many Kenyan species have only dry specimens and live drawings, but no photos of living plants. We need to stop publishing new species only based on just 1 or 2 samples from one locality. We have to go to the field to observe living plants and check herbaria to find the real variation range of species. And when we do the revision work, we should collect multiple samples from different areas for molecular work. And last, clear species boundaries is very helpful to save and use Impatiens and other species better. Thank you very much.
Thank you. Yes, thank you. And we are doing well on time. So we are welcome. Now we are moving away for break, from plants to animals, and specifically tortoise. And then we welcome Jacob to give us a presentation on oming and territoriality on the pancake tortoise. So make sure you note your questions, because there are many presenters, so that at least when you're asking, your question will be specific to which presenter.
So good afternoon. Good afternoon. My name is Jacob. So my name is Jacob from the National Museums of Kenya. I'm presenting on, like he said, unraveling homing behavior, site fidelity, territoriality in pancake tortoise in Kenya. I will begin by just defining some 3 words which you already know. Homing is the inherent ability by an animal to return home if it is displaced. And another closely linked terminology is site fidelity, which simply refers to the tendency of an animal to reutilize or return to a previously occupied area. And the last one is territoriality, which of course is monopolization of space or territory use by an individual or a group. And in this case, a territory is a defended area or an area within an animal's home range over which the animal has exclusive rights. And all these have a great implication on the animal's ability to access resources, therefore also increasing their genetic fitness and survival. Homing is not a new thing. Studies on homing and navigation began with the times of Darwin and others, especially using the homing pigeon, which was known to take message back to the site where it was removed from. And in Chelonians, this homing is very well studied in sea turtles. As you can see, the adults will cross oceans to return to the same beach, and they will deposit their eggs there. When they lay eggs, the hatchlings will go to the ocean, move far, and will return back. That is, they will return to the same spot to lay eggs years later. And in tortoises, however, homing has not been very well studied. And in this, our study, we tested whether the pancake tortoise has the ability to home if translocated. And we also investigated on the issues of site fidelity and territoriality. We did this in Kitui in Kenya. And what is pancake tortoise? This is a very small tortoise, which is unique in that it has a soft shell and it lives in rock crevices. It's only found in Kenya, Tanzania, and a small population in Zambia. The species is highly threatened by illegal collection for trade and again, habitat loss. We used radio tracking, camera trapping, and direct observations to study homing in this species, as you can see from that slide. And what did we do? We had 38 tortoises whose behavior was studied, and these inhabited 12 rock crevices. Herein, I will refer to them as stations. That is from June 2020 to November 2022. Out of those, 13 were fitted with radio transmitters and translocated from their respective home crevices to other crevices away, and roughly 0.8 kilometers, that is straight displacement. And their behavior was monitored daily. Again, we realized homing was taking place. 2 individuals homed
And because we wanted to know whether this is a reality, we collected them and took them to the opposite direction to see whether they will come back. Again, we had some two individuals, as you can see in station 4 and 6. We just interchanged them from their respective crevices to see what would happen. And our results. Pancake tortoises demonstrated a strong ability to return to their home crevices after displacement. 2 females are the only animals that remained or adapted to their crevices. 8 out of 13, that is 61%, successfully homed, returning either to the exact rock crevice or an area within their home range. The retranslocated individuals, again, homed to the very same crevice, and these 2 individuals here that were interchanged, it was interesting to see them. One is moving in one direction and the other one is coming back. They are crossing paths, going home. Sorry for that. A bit about the distances and time travel. The longest successful homing was 6 kilometers in 148 days. Remember, it's a small tortoise, and tortoises are slow. So it covered 6 kilometers in 148 days. But also we had a successful homing within a short distance that was half a kilometer in 3 days. On average, the tortoises moved 2 kilometers within a month. And the longest delay, that they didn't move at the same time. Some moved immediately home, others remained on the site of relocation, and one interesting case remained for 83 days before eventually taking off. That is a bit of mathematics on the distances and the homing days. I will not delve much into that because of time. You can see in this sketch on QGIS, all those are movements by the tortoises, the homing trajectories. And we had to do some analysis to see whether really there's a pattern. So we did the relay test for circular statistics, which tests directional orientation. And the statistic is Z, which is equivalent to the number of movements or bearings multiplied by the resultant vector length squared, as you can see from there. And out of all that, only 2 individuals had a statistically significant directional orientation. However, it was interesting, after doing a pooling of all that data, we realized that there was an interesting trend in that all of them had a statistically significant, the pool data had a statistically significant homing direction. I want to move quickly in the interest of time. You can see from that circular plot, those are the tortoises, each going in different directions. Only these 2, as I showed, have statistically significant directional orientation. And the red line there shows the pooled data. Then, I want to talk about home fidelity. Tortoise movements were mainly observed during daytime. And we observed that females avoided entering crevices on their way, but males did. The males would, however, sleep on, the tortoises slept under dead logs, bushes, and fences, avoiding crevices, which would distract them on their way home. The results of this study illustrate remarkable homing in the species. However, individual movements, as I said, when we pulled the data together, the R is very minimal, implying that they didn't move in a single tightly clustered route. We deduced from that the results that there must be a queue some cue that is directing the tortoises home. And in literature, a number of cues have been studied. Geomagnetic signals, like in sea turtles. Others use olfaction or odor plumes, smell. And lastly, celestial cues like the stars, moon, and the sun. They are known to direct individuals going home. But because our tortoises were closed, translocated in closed boxes, we can rule out one, that it's unlikely they use visual cues when moving home. And, sorry, my computer is misbehaving, but forgive me, please. On site fidelity, remember they moved in rugged terrain. It's not uneven terrain. So this shows the evidence of strong site fidelity, and this is consistent with other studies whereby researchers have known the species to remain in one location over a long period of time. And it is because these crevices or stations are known to offer critical resources to the animals. As I move to finish, we also realized that they have strong territoriality. But as opposed to what has been suggested in earlier studies, this is known to be male territorialism, in that we saw males, direct observations on camera, fighting seriously, and the one which won in that battle mated with the females in the crevice. I finish with maybe this, sorry, my cursor is refusing to work, but you could see some guys throwing legs there. Yeah, sorry. They fight. Those are males fighting for that territory. We also have another example there, maybe as I finish, you could see was a normal behavior during our field study. And in conclusion, these aspects we studied are very important because they will inform conservation of this species. Should we need to translocate tortoises to depleted areas, how far from their homes are we likely to take them? So this is information that is important, but a lot needs to be studied to know, especially the mechanisms they use to go back home. I would like to thank three supporters for that work. As you can see, the National Natural Science Foundation of China, Turtle Conservation Fund, and Mohammed bin Zayed. Thank you.
Yes, thank you, Jacob. I will also want to give some announcements on, after this presentation by Veronica, we'll break for lunch and then convene at 2:30. Then we'll start the presentation after the one which is after Veronica. See this one, it's working. Yes? This one is not.
Good afternoon. My name is Veronica Onduso. I'm presenting my work on one of the chapters in my PhD thesis. And the title, Spatio-Temporal Pattern of Small Mammal Communities Revealed by How Pellets in Amboseli, Kenya. And the authors, my co-authors are Dana Reed, Kay Peresmia, and Ogeto Mwebi. As you know, Amboseli, before the change of governance, was a national park and the surrounding group ranches. And this area is actually affected by climate variability and the land use, which include precipitation that leads to period of dry spells, and also being the community around it, the experiences a lot of pressures from livestock production and the farming. And that's now affect biodiversity. A lot of studies have been conducted to confirm the impact of the biodiversity. But small mammals, the information about small mammals is scant in this area. And this study is trying to fill the gap to start the long-term changes of small mammals in Amboseli National Park over 20 years, tracking the changes by comparing the previous data, the historical data, and the recent data in order to track the changes that are happening with the small mammals and the ecosystem. This study was targeting 3 mammal species, taxa or mammal species, which are rodents, shrews, and bats. And actually, small mammals of this category act as seed dispersers, and they are important to the ecosystem. And they are indicator of species because they are sensitive, they have short life cycles, and they reproduce very fast. And therefore, they are sensitive indicator of ecosystem health, and they can indicate the changes, being the prey for the apex predators. In this case, there is limited information on the changes on what used to be the park, the national park, and the surrounding area, which is the group ranges, because the small mammals respond differently to habitat structure, and therefore this study was to understand how the small mammals respond through the pressures they are facing inside and outside the park. There was also a limited information on using how pellets. Most studies normally use live trapping to understand the changes of the small mammals or the biodiversity of small mammals. So in this case, the live trapping sometimes they bias towards they can capture species which the baits which are used. They can bias so that some species cannot be captured. But in this case, how pellets being a useful tool, of course, how pellets they track the changes, because inside the pellets we have the small mammals skeletal bones, which can be extracted, identified, and be able to identify the species that are there. We are able to get the abundance, richness, and the diversity. In this case, how pellets, which are now, in this case, we used Western Burnau to conduct this research. Western Burnau usually accumulate how pellets for a long time. And if given good conditions, they can stay for long. And if extracted, they can be found even an extinct species, because they trap the skeleton inside the pellet for long. In this case, the material used here at the study area, as I said, is inside the bag, as you see, inside the Amboseli, somewhere called Savari Lodge. And outside the bag, around the Kenya and the Tanzania border, there was a roost site. Those are the roost sites where this western Bano is roosting. So this is where the pellets were collected for the time period 2024 and 204, where 204 and the 2024, the recent samples. Identification of this site was based on the identification of the roost site. That's why this site was selected. And the pellets were cleared in 2020, 204, to make so that the previous now captured the 20 years difference to see the change.